Let's talk about solving system using matrices. So matrices is the plural for matrix. A matrix is a rectangular array of numbers. So for example, the matrix A is equal to top row is 4, 2, second row is -1, 5 is a matrix, or B is first row is 4, 6, 3, second row is 1, -4, 5 is also a matrix. Okay, so A is a 2 by 2 matrix. You always start with the number of rows first and then the number of columns. And matrix B is a 2 by 3 because it has 2 rows and 3 columns. And we're going to use these matrices to help us solve systems. We'll go by hand first and then we'll use technology later. So let's find the augmented matrix for the following system. The augmented matrix, you can see that I have essentially my x's are in one column, my y's are in a column, and then the constant on the right is also a column. So I'm going to build a matrix whose first row is the coefficient on x, which is 3, coefficient on y, which is 2. We'll put a little vertical line here to kind of remind ourselves where the equal sign is, and then the equation is equal to 4. And we'll go in the same order for the bottom one. The coefficient on x is -1, the coefficient on y is 8, and there's our equal sign, and then -2 is on the right. That's our augmented matrix. What we want to do with this, our goal, in other words, is to turn it into something that looks like a 1, 0, some number, 0, 1, some number. The idea behind that being is, well, coming from 3x, we put a 3 here in that first spot because it's 3 times x. So if you look at this row and convert back to a system, this is a 1 times x plus a 0 times y is equal to whatever number you have on the right. And the second row is a 0x plus 1 times y is equal to whatever that number is on the right. So it is already solved at that point. Let's jump into an example of how to do that by hand, and then in the next video we'll talk about how to use technology. So let's solve the system 2x plus y is equal to 1 and a 3x plus 2y is equal to -2 using matrices by hand. The first thing I'm going to do is I'm going to put in that augmented matrix form. So it's a 2x, 1y, 1, 3x plus 2y is equal to -2. Okay, and my goal is to get it to look like this. It's almost what I had above, but if I could get it to here, then I know what y is automatically because the second row is a 0x plus 1y is equal to the number, and then I can back substitute that up into the first one to figure out what x is. Okay, so I'm going to start with, I want a 1 up here, and there's only 3 things I'm allowed to do. I'm allowed to multiply any row by a non-zero number. Can't multiply 0, otherwise you lose information. I can interchange any 2 rows. And the third thing I can do is I can add a multiple of one row to another row, excuse me. Okay, so if I just want a 1 up here, currently I have a 2. The easiest way to do that is to multiply this first row in that matrix by a half. If I do that, I will get 1, 1/2, 1/2. And I'm not doing anything to the second row, so I'm just copying that 3, 2, -2. Okay, so I have the 1. Next thing, I always work my way down. I'm going to go for the 0 next. Currently I have a 3 there. Well, I can't multiply that row by 0, otherwise I lose a whole bunch of information, so I'm going to have to add something to 3 to make it 0. Well, if I add a -3 to 3, that'll make it 0. Well, I'm going to get the -3 from that first row, so I'm going to multiply this top row by -3. I don't actually want to change this first row. I don't want to change that. So I'm going to do some work over here off on the side, but what I want to do is I want to add a -3 multiple of the first row to the second row. And that's too much for me to do in my head, so I'm going to do some work on the side. So -3 times 1 is a -3. -3 times a half is a -3 halves. And then a half times a -3 is also -3 halves. I'm going to add that to the second row. The second row is 3, 2, -2. That's going to build my new second row. So again, I'm not really doing anything to the first row. I'm just going to copy that, which is 1, 1/2, 1/2. And then my new second row is going to be the sum of these two. So -3 plus 3 is 0. -3 halves plus 2. Well, that's a -3 halves. 2 is the same as 4 halves, so that'll give me a positive 1/2. And then a -3 halves minus 2 is a -3 halves minus 4 halves, which is a -7 halves. Great. So now you can see I have that 0 right where I want it. I'm going to move over to the next column because there's no more down to go. I want a 1 there. Currently I have a half. The way that I can make that a 1 is multiply that second row by 2. So not doing anything in the first row. 1, 1 half, 1 half, 0. 2 times 1 half is 1, and 2 times negative 7 halves is negative 7. So if we convert this guy back into a system, the first row is 1x plus 1 half y is equal to 1 half, and the bottom row is 0x plus 1y is equal to negative 7. So you can see I found y is negative 7 already. And if I plug that back into the top equation, I get x plus 1 half times the negative 7 is equal to 1 half. So I get x minus 7 halves is 1 half, which means x is 1 half plus 7 halves, which is 8 halves, which is 4. That means my solution is 4 comma negative 7. The idea behind this matrix multiplication is the fact that you just keep track of the coefficients. You don't have to keep track of the variables, so there's less writing in that sense. And the other idea is that we can feed this into a computer and have technology help us, and they'll do it really quickly. But that's the idea behind what technology is doing by using matrices.